Okay, the next presentation has to do with the balance of power, and that's not the world political stage, but that which comes into our homes, offices, plants, industrial facilities, and also the power that goes back into the power grid from wind and solar farms, for example. Brett Ironside is the President and CEO of MicroPlanet Technologies. He likes to start meetings by plugging a metering device into a power outlet and showing everyone, and I've been in these meetings and in some very new buildings, that on average there's about 122 volts coming into the room, not the 110 that we get used to or think that's coming into our homes. So you've got to take into account that's about a 10% wastage that somebody's paying for. Guess who it is? And also, most people, and I didn't, can't appreciate that additional power, how much additional heat it generates, and what it does to high-tech devices, and what it does to, say, large motors or generators in factories. And Brett's going to get into the cost of reduced performance and reduced life cycles on some of this very, very expensive industrial equipment. Brett is educated in mechanical engineering technologies. He's a serial entrepreneur involved in multiple turnaround and emerging opportunities in many sectors, including hotel, oil and gas, technology, retail, real estate business, a number of things. He was part of the Go Private effort in Alberta many, many years ago when the good citizens got control over their wine and liquor outlets. And as a result of it, we got great pricing power and a lot of variety compared to other provinces. In 1993, he co-founded Goal Energy, a public oil and gas company, which was acquired in 1998 by Tappet Resources, where he remained a director and head of the audit committee, and then that was subsequently acquired and then merged with Crescent Point Energy to create Crescent Point Energy Trust and Starpoint Energy. Brett is on the board of Calgary Economic Development. He's a member of the local finance chair of the Young Presidents Association. And what happened here is that he was strong-armed by the board of directors and a number of shareholders about a year and a half ago. Brett was a director, is a director of MicroPlanet, but he was strong-armed to get the company back on track and exploit the technologies that have been developed over a number of years, the intent, mass commercialization. He's an ardent believer in the technology and, in my opinion, also in his own abilities, and we've certainly seen enough examples of that, that he decided he had to make a small investment. To date, he has invested approximately $3 million in MicroPlanet. With that, I give you Brett Ironside.
Thanks, Howard. Well, I'll try and quickly tell you the high-level story of MicroPlanet. And Howard is correct. I'm very passionate about this company, energy efficiency. I'm a farm boy from Saskatchewan, so wasting anything, whether it be food or energy, doesn't work too well with me. So voltage optimization technology, as Grant was stating, in North America we have a 110-volt grid, so all of our appliances are 110 volts. So you might be surprised to know that the average voltage in North America is 122.4 volts. And so what happens with that voltage is it is usually terminated in the form of heat, and it also shortens the life of all of your equipment. For example, if you increase the voltage on your lighting or light bulbs by 10 volts, it cuts the life in half. So why is the voltage so high? It's a function of ease. The utilities, over decades and now centuries, it was a simple and easy way to just create large infrastructure, push it out there without very much control. 20 years ago, there wasn't much concern about the precision of the electricity that you're receiving. Today, we've got much more precise appliances that we're plugging in. And so the other reason was that it was higher revenue for them as well. So as Grant had stated, the optimal voltage is 114 volts coming to the panel in your home. The electrical code of North America states that you cannot have more than a 4-volt drop from your panel to your farthest plug. The average voltage is 122. The allowable limits are 126. One of the things that I did immediately in joining this company is we had to figure out how we could communicate the benefits to our end users. We had at the time only a green light. Today, we've incorporated the functionality of smart grid metering, or smart meters. And so that now provides us the ability to provide to our end users, to our customers, a scorecard, something similar to this, that can demonstrate to them, as you see on the lower right here, that chart shows your incoming grid voltage, at the top being the red line, quite high and volatile, and then the lower line, the blue line, is the regulated voltage. So just thinking about that for a second, if you think about your home, you have a water meter and a water regulator that regulates the pressure. You then have a natural gas meter and a regulator that regulates the pressure of your natural gas. And then you have a electrical meter and no regulation. We are one of the highest contributors to lead points. All of our work up until the last 3 months has been with the United States Department of Defense and with several large utilities. And so we're just now commercializing this, but the United States Department of Defense, they have a bunch of mandates to lower their electrical usage, and one of the ways they measure that is lead. Their consultant looked at our technology, went through it, and came back to us and said essentially that we had one of the highest quality products for the dollar for gaining lead points for any of those projects. So just the straight reduction of voltage from a high voltage of, call it 122 down to 114 will provide approximately 10% reduction of energy consumption, extend the life of your products, and that's without any change of behavior. That's even more significant as we learn now when we get to industrial and commercial applications. And so if you think of an application where you have three-phase power, which is more of an industrial or commercial, the balancing of those phases, because we balance the electricity so quickly and so precisely, we actually balance and eliminate phase imbalance. And so the ramifications of that are significant, and this is something that we've just come across in the last 9 months of the applications. This chart essentially shows you that in the case that we came up with was the United States Department of Defense on Guam, where they're relocating their Japanese bases. They have $25,000 motors that are downhole in these wells that is producing water for their utilities. And they were having problems getting these motors to last for more than 12 months, when they really should last for 15 to 20 months. They asked us if we could help solve that problem. It was a different application for us because we've always been on single phase, and these are three-phase motors. So we took one of our units and put it on each phase, and then we were able to come up with results that is not in this. There's no picture of it in here, but in the graphs you have in front of you, I think there's a picture of it. The ramifications of that are significant, just much more than the energy savings, though, in the sense that these motors should last 20 years. And so what we learned is not only was the voltage very high and very volatile, but the phases were significantly out of balance. And this chart shows that for every 1% phase out of balance that the power is, that you cut the life of the motor in half. So 3 or 4% phase out of balance, which is common, would bring the life of that motor from 20 years down to 2 years. This is just a chart that shows, it's a compressed chart of your grid voltage supply. So we all know that we have big spikes and sags and all that type of stuff. Our product is the red line in the middle. We essentially sense the voltage coming in at your panel, and we then correct it to plus or minus half a volt. What does $30 million in 10 years of R&D with the Department of Defense and a bunch of utilities buy you? We have the most energy efficient 99.6% through 90% of the load curve. So if you're going to try and create energy savings by managing the voltage, you need to do that extremely efficiently. You can't save 8 or 9% and use 3 or 4% to do it. And that's what some of the older technologies consume. Our technology is brand new and now just being consumed or just being commercialized. Another huge benefit to our technology is a 4-quadrant technology, which is completely different from anything else that's ever been introduced to the market. So that means that we regulate both up and down the voltage, but also in both directions. And so for the last several hundred years, you've had a unidirectional grid where all the power starts at a generating station, is distributed through transmission and distribution to the end user, and steps down as you go. What's happening today is we're now starting to have an active and smart grid where they're taking rooftop solar and micro wind, and they're starting to put that back in at the end, and that is creating huge problems for the grid. It's not an application that they've planned the utilities for, and so the challenge is happening all over the world, less so in certain places in North America, but where you get into places like Australia, solar cities, Hawaii, those types of places. They're getting a solar concentration now of up to 25 or 30%, and the grid is the voltage on the grid is rising and it's becoming unmanageable, to the point that even in the last few weeks there's been articles coming out of Australia and all around the world where the utilities are now going to prevent people from putting rooftop solar onto their homes to generate electricity back into the grid until they find some solutions, a solution which we have. One of our competitors is out of the United Kingdom. It's called Power Perfector. They're using a technology that is, I think it's the next slide actually. The slide on the right just shows a simple step-down transformer, and it takes the existing voltage, brings it straight down to a lower level, which gives you the primary benefit of voltage reduction. Our technology, as you can see, brings it down, and it also makes it perfectly flat. So when I first started looking at this a year and a half ago, one of the places I did is I looked around the world to see what was out there. And I came across this company, which is by far the leader so far. North America is a later adopter than Europe or Australia. And this company in 2008, when I first looked at it, was the 33rd fastest growing private company in England. In 2009, when I got their statistics, they were the 10th fastest growing company in England. And today, they are, according to Richard Branson's Clean Tech and also the Fast Track, the #1 fastest growing company in England. And in fact, voltage optimization, as it's called there, is the top energy efficiency product being sold. The market in England alone for this is about $200 million in 2010, of which Power Perfector had 100 million of that. They are a licensee of an old Japanese technology. There's a company in Canada that is using this old technology as well called Legend Power, if anybody's heard of that. They haven't been doing too well, but it's that technology that I just showed you. So the point of that is that we have a technology that's patented globally, that we're now starting to have distributors around the world. And if you could think of $100 million for one company in one jurisdiction from England, it kind of gives you an idea of the potential of our company. And we just shipped over to the Queensland University of Technology our first 50 hertz prototype, which is the product that we'll be using in those markets. So automatically we optimize the voltage to a desired set point, dynamically lower or raise to that constant level, 99.6% efficiency, and we also can now integrate the solar and wind, which no other technology can do. And of course we have the real-time data that we're providing on a scorecard. Going away from our company a little bit into the industry, of course over the last 5 or 7 years, I'm sure that most of you have followed the solar and the micro wind being the largest sector or the hottest sector. That's started, there's been a little bit more common sense come into that in the last few years. It's not just about creating new and renewable energy, it's about using the energy that we have more efficiently. It's much more economically practical, and it's much more affordable. And so what's happening because of that is there's starting to be a shift of the finance, of course, going into our sector as opposed to the solar side. Again, we have a 4-quadrant design. It's patented. We have 4 US patents, 2 Chinese and 1 European patent. And of course we do, if you think of a surge protector for your house where you buy one for your computer, that's a category A, it's a consumer level surge suppressor. Ours is a category C utility grade, so we'll take a lightning strike and protect what's behind us, but we do the whole facility in one shot. Our uses are commercial and utility, consumer, government, and of course now the renewable integration. This is what our product looks like. Some applications. You'll see on this Wendy's here, this is where we just did this thing where I talked about we had one phase that we were always doing. This is a year or so ago when we first tried this 3-phase where we took one and did it on each 3. Today it looks more like this right here. It's all in one cabinet, and in fact we may have one in the handouts you have there. They show the solar decathlon ones, which were just in Washington. This is an example of some of the utilities that we've been working with over the last few years. The market space we're in is, of course, huge. We're a new technology that clearly is several generations ahead of what's in the marketplace today. We're just going through the process of validation. We just came back from Washington, D.C. Over the last 4 weeks. They had a competition down there called the Solar Decathlon. And what they do there is they invite 20 teams from around the world to build the most energy efficient homes possible, and they build them right on the mall in Washington. 2 years ago when they had that competition, they turned on the solar from all those houses, drove the voltage of the grid so high that it shut down all of the solar generation of all the houses and put the whole competition in jeopardy, again, because they couldn't manage the integration of this renewable energy. We were invited this spring to go down there. We installed our product, 8 of our units there, managed the grid perfectly, and we've made raving fans out of the United States Department of Energy and the National Renewable Energy Labs. But what's happening is all of these companies are in this smart grid space, and they're looking for the technologies and how we're going to integrate these new renewable resources, and we think we're a big part of that. And we think that we're going to be, we know that we're going to have to start to look at who our big brothers are going to be and how we can start to scale this on a global basis. So it's highly scalable. Over the last year, again, what we've done is we've taken our manufacturing process. We've kept all of the intellectual property, thanks Grant, compressed into one place that we can protect, and we can produce that in a controlled environment and then ship that around the world. However, we can have the rest of the product manufactured anywhere in the world, such as Australia, Brazil, England, the markets that we're going to be in, and then we can ship the intelligence and protect our IP. The rapid growth, again, we're looking for these larger partners, and we have several that have come online in the last year. Additional revenue streams such as carbon credits, the data. When we start having this type of data, that provides the data points at the end of what the smart grid, which are part of the central nervous system of where this is starting to go. And of course you have energy savings performance corporations that will spend, there's several multi-billion-dollar corporations that spend money to put it into these government facilities, and they repatriate those funds from the energy savings. And in the UK, as an example, one of the reasons that our competitor grew so fast is they had what's called a carbon trust. And they would pay for 100% of the cost of the product plus the installation, and they would gain their funding back or repay the unit out of the savings of electricity. And now we're starting to see that happen in Australia and other places as well, and those are relationships we've been talking with them as well. So what happened to our stock over the time period? Again, this has been several years of development. My predecessor had made some high expectations which he didn't meet. We were doing one-off projects, but probably the most important things were we hadn't nailed down the value proposition. It's not just about the energy savings, it's about the power quality, it's about the renewable integration that really make us stand out from the others. And the Solar Decathlon with the Department of Energy has really validated that for us. Now when we go out there, instead of the different groups going, okay, so how do we know this is really that legitimate? How does it work? We hear these stories all the time. This sounds almost too great to be true. Now we can send them to the new National Renewable Energy Labs or the Department of Energy, and they validate it for us. And of course, we've reduced our burn rate and moved everything along. So why now? We're starting to get the sales with the product moving forward and the validation. We've got some repeat orders coming in, carbon trusts. Of course, we're scalable. We've brought our costs down. As Grant had mentioned, we have a very strong board of directors and a strong management team that has a vested interest that's aligned with the shareholders. Clean tech, one of the top spaces, voltage optimization becoming one of the top products in that space, best-in-class technology, we're solving the renewable integration problems.